Attention all personnel, this is the Test Control Coordinator. We welcome you to the static test of Launch Abort System's motor ST1. Prepare for countdown. T-minus 60 seconds. High-speed digital operators start the VT-1432 recording system. T-minus 40 seconds. T-minus 30 seconds.
2.
You're watching NASA Edge.
Launch ready. DLC. DC go. FPS.
Welcome to the big show.
First show of 2010, actually.
First show of 2010.
Absolutely.
Guys, how you doing?
Doing
Pretty
great.
good. It's good to be back in studio again.
Yeah.
Comfortable. It's a little cool. That's why I've got the jacket, but I'm feeling good.
Yeah, I think it's warm in here.
Yeah, which is kind of odd. But anyway, we do have a great show today. And what are we going to talk about, Chris? We're going to talk about the Launch Abort System.
The Orion Launch Abort System.
Good clarification.
Which is part of?
Yeah. The Constellation program.
That's right. In fact, we have a jam-packed show today, Franklin. We're going to be looking at the different components of the Launch Abort System. What is the Launch Abort System, or LAS?
That's LAS, Franklin Launch Abort System.
Yeah.
At Los Angeles.
We found that in our past years of covering the different tests, that there are a lot of young engineers working on the Launch Abort System, and we're going to meet some of those today.
Sure.
And then finally, we have a treat. We have Kevin Rivers, who's the project manager for the Launch Abort System.
In studio,
which is based here at NASA Langley Research Center. We'll be here to give us an update what's been going on since those tests.
Well, I don't want to just push things along, but I'm really curious. We need to know what the Launch Abort System
And
is.
I think Brian from Orbital had a chance to take us right along the Launch Abort System and explain all the different components.
Yeah, we actually got a tour of it during a test.
That's
so
right.
Let's take a look.
Cool.
Well, what we're doing today is performing what's called a modal test, and what we're trying to do is find out basically how stiff or how flexible the vehicle is. And that's important to the guys that are trying to fly the vehicle.
So essentially, it's a vibration test.
Exactly. This is the adapter cone,
right.
is what it's called.
And this would attach to the crew module.
Right.
Okay.
And for this test, the crew module actually is important, and so we have this crew module simulator here.
Okay.
It's about 17,000 pounds of steel, just welded together, and it simulates the mass of the crew module.
Gotcha.
Right, not the look of the crew module,
No,
because I did
it's-
not recognize it at
pretty
all.
ugly.
Yeah. Well, it's utilitarian but functional.
That's right.
That's right. Now, the next section you have here, of course, is the abort motor.
Right.
Okay.
So the adapter cone comes up here. It actually handles up to 750,000 pounds of force. This motor is exactly like the flight motor, except there's no propellant in it. We use rubber in it to get the same mass.
Right.
But we don't want to take the risk here and just ground test.
Plus, with all the vibration and stuff too, you don't want to take unnecessary risk. Now, did you feel that, Chris?
I did.
Because actually, you don't see it shake much, but literally, you could feel it on that last one up here.
I think he was getting a little worried there. So basically, from here up to here is the jettison motor.
Okay.
And what we do is, when we do an abort and we're finished with a launch abort system, or in the event of what we hope to be always a normal launch,
right,
we got to get this thing off so the crew module can continue to orbit. So that's what this is used for. The propellant is in here, and then there are 4 nozzles. You can see one covered by some plastic, again, to keep water out and other
nesting
things out.
animals again.
Right. So that's interesting. So you've got the abort motor with the solid propellant down the sort of like a reverse flow.
Exactly.
All right. And then so for this jettison motor, you just have a very small amount of propellant.
That's right.
Okay.
It's on the order of 600 pounds, about 40,000 pounds of thrust. Again, it doesn't take a lot to get it off the vehicle and out of the way.
Because it's not carrying the mass. That's
Exactly.
17,000, what's it, 17,000
pound crew module.
Yeah, so you're carrying much less. Perfect.
Okay.
It's like you guys actually planned this.
It's genius, isn't it?
It's so simple yet brilliant.
And then, of course, we have the attitude control motors here.
And what you see, we've got 8 valves. Here they're simulated, but on the real thing, there are 8 valves that actually will allow hot gas, 3,000 degree Fahrenheit gas to come out of the various nozzles. And we can tell it to, for example, if we want to pitch the vehicle in a certain direction, what we actually do is about halfway through the abort is flip around,
Right.
so that the launch abort system comes off and we leave the crew module flying heat shield forward,
Exactly.
ready for entry.
Now, for each of these motors, from the abort motors to jettison and attitude control thrusters, are you using the same type of solid propellant for each one?
Very similar.
Very similar.
Each one has different recipes, but essentially it's the same materials. Yeah.
Recipes. That's an interesting term. So you got like people in a sort of rocket kitchen
Oh, yeah.
formulating their.
There is a science to cooking.
Yeah, that's true.
That's right.
We've learned that. That's
We learned
true.
that before. Well, in fact,
rocket science to cooking.
On the abort motor, they have this huge mixer. They put all the materials in there, and what they did is they took the design for a bread mixer from a kitchen, and they scaled it up, and that is how they mix their propellants.
Did they toss it like the pizza dough and?
No.
No, okay.
Oh well, yeah, can't get them all right.
Well, the cool thing about this is probably the most the state-of-the-art launch abort system ever made. I mean, we're actually seeing the first model here. That's right.
And they let me in. Now, are you going to be the one that actually pushes the button
I
for
wish.
the launch?
I wish. No.
Do they have an in-house lotto for that, or how does that work?
The computer always wins.
You're a part of something that is going to save the crew's lives, but hopefully will never be used.
That's right. And
In that capacity. But it will be jettisoned, of course. But I mean, in terms of an actual abort, I mean, that's
right. You know, that's something that really hit home with me in the very beginning, is that we will probably save the lives of the crew at some point. We hope it's never used, but history has shown us that it's very probable that this will be used someday. And to know that when that crew comes back, you know, I think about their kids, you know, and I'm responsible for bringing their parents home to them. That's very rewarding to me.
Wow, that was a pretty interesting segment. Brian had a lot to share with you guys.
You know, it's just amazing to me to think that all these components are involved in the launch abort system. I mean, there are how many motors on there? Well, lots of motors. Lots of motors, parts of other motors. Just it's a motor fest. It's like a muscle car convention.
well. Don't forget you have the abort motor, the jettison motor,
Right.
and the attitude control motors.
Yeah, which is actually a collection of motors, and then the others 4.
But remember, guys, this is the system that's going to protect the astronauts in case something happens either at the pad or on ascent.
or the real threat of one.
That's right, and that's the key. So tell you what, let's take a break, and then when we come back, we're going to talk about some of the engineers that are actually working on the launch abort system, some of the young engineers.
And all these systems, how they kind of come together, how they all have been brought to where they are now.
Hey, you're watching NASA Edge.
An inside and outside look at all things NASA.
4, 3, 2.
Hey, welcome back to NASA Edge.
Yeah, and continuing our discussion of the Orion Launch Abort System, the big question that I had coming out of our last segment, hearing Brian's explanation was great, but, you know, like there was the motor test out at ATK, which is one place out in Utah, and then
Right.
the modal test at Orbital, which is in Northern Virginia. So all these things are happening kind of all over the place, and I'm just thinking, how does all this come together? How does this all fit together so that it will be the launch abort system?
It's like building a football team. You know, you got to get your best receivers coach. You got to get your best defensive coordinator. And you got to pull them all together, and that's how you come up with a good, winning, strong team.
That's true. That's actually a great point. You know, in terms of looking at for NASA for the launch abort system, you know, the project management is actually here at NASA Langley Research Center.
Right.
And then of course we have a prime contractor, which is Lockheed Martin.
Yeah.
All right. And then also we have ATK as a subcontractor with Orbital, and there's other contractors below them. So we have a lot of people working on this particular piece of hardware.
I'm just confused. Is it the NFC East or is it the AFC or are there any undrafted picks in there?
NASA just put together a team of ringers.
Well, actually, that's an excellent point, Franklin, because we actually met some of these people, these players, if you will, that are on the team out at ATK and at Orbital, and they did a pretty good job of you get a sense that they're in there getting their hands dirty and really progressing nicely.
But just like the football teams, right?
Yeah.
You get your veteran engineers, and then you have to draft some young engineers.
That's right.
For the team, because you have to kind of gotta mentor them along so they become eventually veterans.
Well, clearly NASA's confident to play some rookies.
Because we had a chance to talk to some of the young engineers that are working on the launch abort system.
Yeah, and before we roll the video, note one thing about these engineers, these younger engineers and whatnot: no slide rules. I didn't see one slide rule. Check it out.
Right now we're doing a test on the launch abort system configuration to see what the natural frequency is of the vehicle. It's important that we are able to correlate our analysis models with the actual as-built configuration. So basically what we're going to be doing here is shaking the vehicle, taking a lot of measurements, and we'll be correlating that with our math models and analysis models to make sure that all of our predictions are accurate.
And we want to make sure that this particular launch abort system doesn't match the natural frequency of the spacecraft.
That's exactly right. The launch abort system has its own natural frequency.
Right.
All structures do. And you want to make sure that that frequency doesn't couple with the launch vehicle or the spacecraft.
That's kind of like when you hit the right note and the glass is shattered.
Exactly, and I'm sure you've done that.
That's a good analogy.
Yeah.
Now, when you assembled the launch abort system here, did you start from the adapter cone and work your way up, or?
We actually made the abort motor to the jettison motor first. The abort motor is sitting on one adjustable dolly and one fixed dolly. So you want to mate it to the jettison motor because that's also on the adjustable dolly. That way, if those two are mated, we can lower the fixed dolly and we can adjust the entire structure to the adapter cone.
Gotcha. Interesting. Test director in only 6 months?
Yeah.
How do you get to be test director of a modal test in 6 months?
I don't know. I just got really lucky.
He's only a co-host. It's been almost over 2 years. So what's that involved in terms of being a test director? I mean, what do you have to go through in terms of checklist?
A lot of what I did was like planning type stuff. Like I had to make sure that all of our test plans are all worked out, and everyone who needs to review them has seen them, and we all agree that these are the things we're planning on doing. This is the way we're going to do it, and these are the steps we're going to take, and make sure everyone is in agreement that these are things we really can and want to be doing.
I'm a propulsion engineer working on the abort motor, which is the main motor on the launch abort system.
So Heather, we've done some research on you, and we noticed that you played basketball.
Yeah, I did. I played for 2 years as a forward at a Division II school called Colorado School of Mines.
Now, how does being a propulsion engineer compare to being a forward on a basketball team?
You know, there's a lot of similar qualities between the two. Everyone on a basketball team, has a different position and plays a different role on the team, and it's really the same thing even in engineering and on the Orion program, because everyone has a different skill and a different quality that they can offer to the team. So,
any bench clearing brawls come up on the engineering side? Any of that
at work?
Yeah, I haven't been able to use those skills yet. I'm still working on that.
Technical fouls or anything?
Technical fouls.
Like everybody drop your protractors and go to your corners and come out fighting.
None of that? No?
No, but no, I haven't.
So tell me, Franklin, do you think Blair can dunk on Heather?
No, he's not even close.
Hey, Franklin and I, first of all, Heather and I had an opportunity to get I actually challenged her in basketball one-on-one.
To a game of Orion?
Yeah, to a game of Orion out at ATK. But unfortunately, the schedules conflicted. So I've been stepping up my game. Franklin's been showing me some pointers. She's in trouble if we ever meet again. All right, Franklin, get ready for a big move. Here it comes. Yeah, and by the way, Heather, if you're out there watching the show, and I know you do, game on next time we meet.
Well, I tell you what, I think...
Oh, wait, no, and you had an interesting observation.
What's that?
The pockets.
Oh, the pockets. Oh, yeah. You know, we had these ATK and orbital, what do you call them, smocks?
Yeah, I'm trying to think of a more manly word, but it's just not happening.
The pockets were cool, because how often do you find yourself in this position with your hands in the pocket? When you walk around?
All the time.
You know, I really like the outfit. I mean, just
the lab coats.
The lab coats, and I mean, you find your hands in the perfect position. How many hours a day are you in this position?
In this position?
Yeah, walking around.
This is a part of safety. Keep your hands away from touching any of the hardware.
The way the pockets were designed into smocks, it was just at the right angle and the right position. Man, I felt like a doctor the whole time.
Pencils are key.
Doctor? That's serious for a couple minutes. Is that these young engineers, just imagine, they're working on a multi-million-dollar piece of hardware.
It's quite a rookie class NASA has out there.
Yeah, and then of course, well, Henry, I wouldn't put Henry into that class because, like I said, you said he's the Brett Favre of the people that we interviewed.
Yeah, I mean, you know, he's seasoned. He's a little more seasoned, you know. Yeah. I wonder if they get in there every year. I wonder if Henry's going to retire.
But he could lead his team to victory. Yeah, I'm sure he probably will.
Hey, you never know.
Just think what these young engineers are doing now. For when we, eventually when we go back to the moon, to Mars and beyond, or to another asteroid.
And Franklin, you can hear the enthusiasm. They're excited about being part of the space program and about what eventually will become our return to the moon.
Right.
And I'm sure this is exactly what it looked like with your veteran engineers now, what they looked like back during the beginning of the the Power program.
Right.
They were all excited, fresh out of school, engineers just working on a project, and these kids are going to be working on this project probably for the rest of their lives.
Mm-hmm. Let's hope so. Because they're quality folks. You can't let them get away. You got to lock them up with a long-term deal.
But I tell you what, I understand. Just heard Ron in my earpiece that Kevin Rivers is here. He's ready to go. And so let's go ahead and take a break. And when we come back, we'll get an update on the Launch Abort System and see where we're heading.
Where it is currently.
And the future.
The next few months. Okay. All right. You're watching NASA Edge.
An inside and outside look at all things NASA.
T-minus 15 seconds. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Four, 3, 2.
Hey, welcome back to NASA Edge.
Hey, we have in the studio today Kevin Doc Rivers, the program manager for LAS.
I like that, Doc.
Doc?
Yeah, well, we've been mixing our sports metaphors a lot here today. And also, do not be thrown by the incredibly hot-looking smock that I'm wearing. These are the ones that Chris talked about with the perfect pocket. So this was in your honor, Chris.
How did you get a hold of one?
I can't really talk about that. But ATK, don't worry, it will be returned to you.
I'm going to call Trina right after the show.
No, don't call Trina. Yeah. She won't let me come back.
So, Kevin, thank you for coming on the set with us this morning.
Well, Chris, thanks for having me. It's good to be here.
Over the course of the show, we've been talking about the Launch Abort System and kind of giving a look at a couple of the tests over the past year. But we want to know what's been going on with the LAS recently and as we look towards the future as well.
The main focus that we've been emphasizing over the last year, of course, has been trying to develop our attitude control motor, ACM. Mm-hmm. The ACM is the motor that's on the very tip of the Launch Abort System. This is the motor that actually drives the Launch Abort System through the trajectory that it flies in the event that we have to abort.
Which was confusing for me. When I heard attitude control, I sort of had flashback to many disciplinary moments that I went through in my life. But what does that actually mean, the attitude control?
Well, attitude as in orientation.
Gotcha.
Not attitude as in,
bad attitude.
Bad attitude.
Well, let me get this straight here. I just want to clarify for the audience out there. You have 3 sets of motors. You've got the abort motor, which is the ones that you see here, right? Mm-hmm. And then you have the jettison motor and then the attitude control motor.
That's right.
Now, if in case there is an abort, either at the pad or an ascent, the first motor that will fire off is the abort motor?
That's correct.
Okay.
So in the event that there was some kind of anomaly that was sensed by the system in the Orion that makes the decision whether or not to abort, the abort motor would light. And then immediately after that, the attitude control motor would engage and then begin to direct the vehicle as it's accelerated away from the rocket onto an appropriate trajectory so that it can move out, get away from the explosion or event that's occurred, and then it actually also reorients the vehicle. So it's flying away from the rocket, and then it'll turn the rocket around so that it can prepare to eject the capsule out of the bottom of it.
And then the jettison motors would actually fire off, and that launch abort system would shoot off. off.
Right. Once it's reoriented and ready to go, then the jettison motor fires, and that releases the capsule
off to safety.
Off to safety.
What is the response time for that system to react compared to that of like an impact of a car and like an airbag would deploy?
I would assume it's a little faster than an airbag deploying, but it's like milliseconds for it to actually begin to work. Yeah.
Wow.
Now, is this something...
milliseconds to a thrill ride that you won't forget.
Yeah.
Either,
yes. Now, out of those 3 motors, I understand that the attitude control motors, that's like an engineering novelty. It's one of a kind.
Yeah, actually, there are 8 valves going around the periphery of the rocket. Each one of those valves can be opened or closed at the same time, and this is a one of a kind. It's a first of its kind. It's not the first solid rocket. It is a solid rocket motor, as the other motors are, and we do that so that we can try and be relatively environmental, because the liquid systems that we might use are hazardous, and if we don't use this system, it gets dumped into the ocean. We don't want to be poisoning the ocean. So anyway, we do this with a solid, which is pretty inert.
It's green.
Yeah, pretty. But there are motors like this in existence, but they're smaller. There's nothing ever been built of this thrust class.
Oh wow!
Which is about 7,000 pounds of thrust in any one direction. It's at least an order of magnitude bigger than anything else that's ever been built. So it's been a very complicated motor. I would even say difficult.
But you've had some successful tests with that motor.
Yes, we have. Actually, we performed a lot of hot fire tests where we actually took one valve and fired it. And then most recently in December of 2009, we actually fired a development motor, which is a full-scale test, a full-scale motor with all 8 valves. They were all active and operating. Essentially what we were doing is we were demonstrating that we could command thrust in any direction, that it's thrusting on one side and then flipping to the other side. And then the test actually concludes with a really neat round robin demonstrating all of the valves operating at their full thrust capability. And it actually looks a little bit like a lawn sprinkler or a flamethrower, when you watch it, because you actually see the plumes moving around the motor during the test. It's really neat to see.
What's up next for the LAS testing system?
Okay, so all of this has been leading to what we're calling Pad Abort 1, which is the next the first flight test for Orion. And most of our work obviously has been focused on developing the hardware that we need to do that test, like the attitude control motor, as well as just getting ready to be sure that we're going to have a successful test. So we've spent a lot of time in the last couple of months focusing on verifying that the design actually is going to perform as we designed it.
That is so cool, and we're going to be there at the White Sands Missile Range to cover Pad Abort 1.
Yeah, and this is
later this year.
It's kind of interesting because when that test takes place, you're testing not just one system, but obviously all 3 stages in one test, which will be quite impressive.
Well, cool. Well, Kevin, thank you very much for taking the time to come out here today. I know you're a very busy man, and we can't wait to Pad Abort 1 coming up later this year.
And you'll be at Pad Abort 1, correct?
Yeah, I'll be there. Look forward to talking to you there.
Well, we'll talk to you then.
Great.
Hey, you're watching NASA Edge.
An inside and outside look at all things NASA.
It should be fantastic.
That ACM is pretty cool technology.
It is.
Can Blair get a ride?
I hope so.
In your 40, 50, 60 plus years with the agency, depending on how you
60,
look at it.
it's got to be 60. I mean, that's just me.
What are some defining moments in your career?
Working with Orville Wright was the high spot of my career. And
incidentally, he said the same thing about you.
But we were always very close.